In math class today, 8th grade, we're going to take a look at our cumulative test divided by 4 so I can get the price per can. And then I'm going to say outcomes. So the options of getting 1 out of 1 is 1 out of 1, 2, 3 different pathways, because this is one pathway, this is one pathway, this is one pathway, and this is one pathway. So 1 out of the 4 other total is the number of probabilities that you have for spinning 1 both times. Number 4, describe the shape of a graph that represents the following situation. A rocket is launched up in the air and falls back to the earth. The graph relates to the time the rocket's distance. It's going to show this representation of how this rocket's going to go. The rocket launches up in the air and then eventually falls back down. The graph kind of looks like, if you turn it upside down, a U. So I'm going to describe it as an upside down U. Number 5, simplify the expression a to the negative 6th, b to the 5th. We know that our negative property of exponent tells us that this is negative here, it'll be positive there, so we move it down here, and I can now rewrite my overall equation with a 1 in the numerator because that was moved, and then the 2 other variables, a to the 6th, b to the 5th, in the denominator. For number 6, it says to simplify 2.38 plus negative 1.92 minus negative 6.22 to get plus 3.47. What I want to do first is set this up as an addition problem. So I'm going to say 2.38 plus negative 1.2 plus the opposite of negative 6.22 plus 3.47. Once I've done that, then I can identify the positive values that I have and put those positive values together. So I'm going to write these all over the top of each other. 6.22, 3.47, and 2.38. And sorry, that's a 3 right here, 2.38, and write this out as an addition problem together. In this example, I'm going to say 2 plus 8 is 10, 7 is 7, carry the 1, 1 and 2 is 3, and 4 is 7, and 3 is 10, carry the 1, 6 and 3 is 9, and 1 is 10, and 2 is 10, 12.07, and then I'm going to subtract from that 1.92. 12.7 subtract 1.92 to get my overall final answer. To set that up, I have to make sure that my decimals are lined up and then do the subtraction. 7 minus 2 is 5. The 0 and the 9 I'm going to borrow here. The 2 turns into a 1. This turns into 10. 10 minus 2 is 1. 1 minus 1 is 0. And 1, I'm going to get 10.15 as my final answer. Number 7, Mr. Ramirez is buying square tones to cover his patio. Square stones, not tones. Sorry. The patio measures 7.5 feet by 9 feet. So it's not quite a square, somewhat like a rectangle like this. We would say 9, 7.5. Each stone is 6 inches on a side. If Mr. Ramirez buys 275 stones, are there enough stones to cover the patio? So we have the area in feet, and he has the area of each stone in inches. We got to make sure that we can convert inches to feet or feet into inches. And here in the description below, the hint, it tells us what 1 square foot equals, as in 144 square inches. And then it gives us another hint. Divide the area of the floor by the area of one tile. Use inches squared. So let's find the area of the floor, divide it by or transfer this from feet into inches, and then see how much area the tiles actually would make up if we're given that many overall tiles. So each stone is 6 inches on a side. So the stone is a square that has a 6 inch by 6 inch measurement. If I'm going to find the area of one of those stones, I multiply 6 times 6, which is going to give me 36 inches squared for one of those. And I have a total of 275 of them. I would multiply 275 by 36. Now that's to find the total in inches squared. The second thing that I'm going to do is multiply 7.5 times 9 to get my total value or total area in feet. And then that total area in feet needs to be converted to inches by saying that one of those equals 144 square inches, so I'm going to make that conversion. Are there enough tiles? what I want you to make sure that you can do is multiply 9.7.5 and then change this answer in feet squared, multiply by 144 to change that into square inches. 1 square foot equals 144 square inches, and then compare that to what you get in the total square inches here. If this number is larger than that number, then he has enough tiles. If this number is smaller than that number, then he does not have enough tiles. In this case, we would say yes, because 270 stones will be enough. Mr. Ramirez needs 270 stones to cover the paddle. So yes, there are enough tiles. Number 8. Identify the property illustrated. 6 plus 7 plus 4, 6 plus 7 plus 4. Notice that the parentheses changes where it is. It kind of changes the grouping that it's in. You know that as the associative property because 6 and 7 were associating with each other. Now in this one, 7 and 4 are associating with each other. So we have the associative property of the operation is addition. Number 9. Write 3 divided by p in words in 2 different ways. So I just gave you one of them. The other way in which you could write it would be the quotient of 3 and p. Number 10. Graph the equation y equals x plus 1 using a table. Decide whether the graph represents a function and whether it is a linear or non-linear function. Here in the hint it says evaluate the function for x equals negative 2, negative 1, 0, 1, and 2. So I'm going to set up my x and y chart just like this. For x, I'm going to plug in negative 2. I'm going to plug in negative 1. I'm going to plug in 0, 1, and 2. And then in the actual equation, plug those values in. So what if x equals negative 2? So if this is negative 2 plus 1, I'm going to have negative 1. If it's negative 1 plus 1, I have 0. If it's 0 plus 1, I have 1. If it's 1 plus 1, I have 2. If it's 2 plus 1, I have 3. And if I would graph those points on the overall graph, here's what it would look like. You'd have over 2 down 1, over 1 down 0. It would be 0, 1, it would be 1, 2, and it would be 2, 3, and here's my line that goes through it. If I draw any vertical line on here for the vertical line test, I can see that it is a function. So the graph is a linear function. The graph does represent a linear function. On the back side, number 11. A theater group has prices for tickets. The tickets' first cost will be $8, with each additional ticket will cost $5. Write a rule to model the situation, then use the rule to find the total cost of 13 tickets. Then M represent the number of tickets, and C represent the total cost. In this case, you have your initial price, which is going to be A1, and then you have the next total value minus 1, because you're not considering that first ticket by what your common cost is for each additional ticket. So to plug that into our equation, you would say that the initial cost is 8, and it's n minus 1 saying, well, how many tickets can be sold? The common difference between each ticket after that is $5, so you're going to plug in 5 here, and this is going to be n minus 1. So the total cost that we're looking to make sure that we can meet is when you have 13 total tickets, then that value goes into this evaluation. So you'd say 13 minus 1 is 12. 12 times 5 is 60. 60 plus 8 gives you a total of $68. Number 12, graph the ordered pair, negative 4, negative 1. Negative 4 means I go this way. 4, negative 1 means I'm going down 1, so we're right there. Number 13, find the x and y intercepts for 6x plus 4y equals 12. To find the x-intercept, I plug in 0 for y, so I'm going to plug in 0 here. 4 times 0 is 0, so my new equation looks like this. 6x equals 12. To find the y-intercept, I plug in 0 for x. That would be 0 here, so I would get the equation 4y equals 12. Now I can solve for each of what those x values would be, or those y values would be, in those two equations. Here I would divide by 6, x equals 2. Here I divide by 4, y equals 3. So where x equals 2, I have 0, and where y equals 3, x is 0. Here's my ordered pairs for where those intercepts fall. Number 14, 0.63 of 12 is what number? Of means multiply, so you're going to multiply 0.63 times 12. When you multiply, you can multiply just the number 63 times 12, but then come back and move your decimals 2 places to the right because you have 2 decimal places that are being multiplied. You're going to get a total answer of 7.56 when you multiply those. Number 15, solve 2/3 x equals 8. Solve for x. That means get x by itself. When x is next to something that's being multiplied, the best thing to do is to divide. But in this case, there's a fraction there, so the opposite of dividing by a fraction is to multiply by its reciprocal. So I take 2/3, and the reciprocal of that is flip it, would be 3/2. That would cancel those out. What I would do on one side, I do to the other. So on the other side of the equation, I would have x times 3/2. Sorry, I would have 8 times 3/2, so 8 over 1. I multiply numerator by numerator, denominator by denominator. 8 times 3 over 1 times 2. The 2 and the 8 can actually cancel before I get into the multiplication. I say how many 2's go into 2? That would be 1. How many 2's go into 8? That would be 3. 3 times 3 is 9. 9 over 1 would be my final answer. Sorry, how many 2's go into 8? That would be 4. 2, 4, 6, 8. That would be 4. 3 times 4 is 12. That makes more sense. Number 16. Here you've got 6c minus 3 minus 2c equals 4c plus 4c. Justify each step. So justification means that you're going to write in what you're thinking of and what you're doing in terms of the mental math that's going on as you're going through the overall work. In this initial problem here, you've got 6c and 2c and 4c. So you're going to try to combine like terms. Combine like terms means that 6c and 2c can get put together on this left-hand side of the equation. You've got 6c minus 2c, which is going to give you 4c. 6 minus 2 is 4. Now I have 4c minus 3 equals 4c plus 4. Now the next what I'm going to do in terms of properties of equality is to try and get the same items on the same side. So I'm going to subtract 4c from this left side. That means I have to subtract 4c from this right side. If I subtract it from this left side, it's actually going to cancel it out. And what I'm going to be left with on this side, this would be the subtraction property of equality. I would have 4c minus 4c cancels out, so I got negative 3 equals 4c minus 4c. That cancels out positive 4. Uh-oh. Since negative 3 does not equal positive 4, this is a false scenario. So this is not a true situation. This would say this is never true. Negative 3 does not equal 4, so therefore there is no solution to this equation. In number 17, I'm using a similar method in justifying each step. I have 5d plus 2 times, in parentheses, 2d plus 3 equals 42. Solve for d. Well, the first thing that they're going to do is blank property. It gives you kind of a hint by having this written over here. They have 5d plus 2d. Looks like I'm going to use the distributive property to multiply this out. I distribute. 2d times 2d is going to give me 4d. 2d times 3 is going to give me 6. And now I can, in this line, combine like terms. 5d and 40 is 9d plus 6 equals 42. Now I'm going to subtract. Because I do it to both sides, it's the subtraction property of equality. I've got positive 6. I'm going to say this is 9d plus 6 minus 6, so that those cancel. What I do to one side, I do to the other. This is minus 6 on this side. So now I have to calculate 42 minus 6. 42 minus 6 in this case is going to give me 36. And now I would have 9d equals 36. Looks like in this portion I have the blank property of equality where I'm multiplying. Probably means that in this case I've got the multiplication property of equality. Because I've got 90 here, what I'm multiplying to get rid of that 90 is actually 1/9. It's also the same thing as dividing by 9 on that side. What I do to one side, I do to the other side. So these would cancel. That would leave d on this side, and I've got 36 over 1 times 1 over 9. 9 and 36 can cancel here to reduce each other. How many 9's go into 9? 1. How many 9's go into 36? That would be 4. D equals 4. Here I would write in my justification, simplify. Number 18. The value of the square root of 118 to the nearest integer is 11. Well, to the nearest integer, when I'm thinking square roots, I have to think perfect squares. So perfect squares, think of what you know. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. Okay, so square root of 118 falls in between 10 times 10 and 11 times 11. It's probably closer to, and it is closer to, square root of 11. than it is in terms of, or sorry, not the square root of 11. It's probably closer to 11 than it is to 10 because 118 is a lot closer to 121 than it is to 100. So it's nearest to 11. 19. Evaluate negative x, 2x plus 3y plus xy for x equals 1/2 and y equals 1/4. In this case, I would rewrite the expression. In full form, I have negative 1/2 multiplied by inside parentheses 2 times 1/2 plus 3 times y, which is 1/4, plus 1/2 times 1/4 on the outside. And now I want to work on what is the inside of this parentheses. First, 2 times 1/2 is going to cancel out. That's going to be equal to 1. 3 times 1 over 4 is going to be equal to 3/4. So I get 3/4 here times negative 1/2 on the outside. Plus, here I have also on my parentheses on the inside, 3 times 1/4, sorry, that was 3/4 here, that's my answer. Plus on the outside here, I've got 1/2 times 1/4 because that's the x and y on this outer portion. So it's 1/2 times 1/4. 1 times 1 is 1, 2 times 4 is 8. So my next overall equation is going to look like this. Negative 1/2 times 3/4 plus 1/8. In this case, I'm going to multiply 1 times 3 is 3, 2 times 4 is 8. So I get 3/8 plus 1/8 is going to give me 4/8, or it's equal to 1/2. Number 20, solve for s. 4s minus t minus 5 equals 2s plus 3t. Use inverse operations to isolate the variable. That means get s all by itself. First thing that I want to do is get the s's on the same side. So I'm going to minus 2s from this side, minus 2s from this side, add t, and add 5. To rewrite all that, let's just do the math vertically here. 4 minus 2 is going to give me 2s. T and t is going to cancel. 5 and 5 is going to cancel. 2s and 2s is going to cancel. 3t and 1t is going to give me 4t. And then I had plus 5 on this side. And then I would divide by 2, divide by 2. In this case, my final answer is going to be, well, 4t divided by 2 is going to give me 2t, and 5 over 2 is going to remain a fraction, in this case, 5/2. Okay? Those are the practice problems for your practice test. You can use this video and the notes from your practice test to help you complete your test 7A tomorrow. God's blessings.